Hello students, welcome to my class. In this video we are going to be discussing about velocity of the transverse wave problems we are going to be discussing. Let us see the first question. A transverse wave is propagating on a stretched string of linear mass density is given as 3 into 10 power minus 4 kg per meter is represented by a equation y equal to is given as 0.2 sine 1.5x plus 60t is given, where x is in meter and t is in seconds. The tension in the string they're asking. Now here let us see. So velocity of the transverse wave, the formula will be getting as v equals will be getting as root over t by mu will be getting. T is nothing but tension in the string will be calling tension in the string. And here mu will be calling as linear mass density will be calling and here this value is given. So here 3 into 10 power minus 4 is given. This is per kg per meter. It's a mass per unit length. Now here y value is given as 0.2 sine, it's 1.5x plus 60t you can take. So general equation of the wave you can take y equals to a sine, this is kx plus omega t you can take. So instead of omega here it will be 60 will be there, and instead of k here will be having 1.5. Now velocity formula, v equals will be taken as root of omega by k. Omega will be getting as 60, and here you can get it as this is 1.5 you can take. That means here you can take as 60 by this is 3 by 2 you can take, or this is 320 times 22 0 will be getting as 40 will be getting. Now here you just substitute this velocity value in the first equation. So here when you are taking here this is, so v square which will be equal to root over t by mu, you just square on both sides, t by mu will be getting. So we need to calculate the t value. T equals will be getting as v square into mu. So velocity we calculated as 40 whole square into will be getting as mu value, it is 3 into 10 power minus 4 you are getting. So it is nothing but here will be taken as, so this is 1600 into you can take as 3 into 10 power minus 4 you can take. Here 2 zeros gets cancelled, minus 2. 16 3 0 will be getting as 48 will be getting 48 into 10 power minus 2. So here that means here so tensional force will be getting as 0.48 Newton will be getting. So 0.48 Newton is the correct answer. Let us see the next question. The next question says a transverse wave described by the equation is given. So here y equals it is given as 0.02 sine, and here it is given as x plus 30t is given. And here where x and t are in meters and seconds is given, is traveling along a wire of area of cross section is given as 1 millimeter square is given. So now here linear mass density is given as 8000 kg per meter cube. What is the tension in the string they are asking. Now here it is in the form of y equals to, you can take as a sine kx plus omega t, general equation of the wave we can take, where k equals to 1 you are taking and omega equals to you can take as 30. Then velocity of the wave formula will be getting as v equals to omega by k, it's 30 by 1 you can take, which is nothing but 30 meter per second. Now here you will be getting as velocity of the transverse wave formula will be getting as v equals to you can take as root over t by mu, and here they have given as area of cross section and the density of the wire is given. So here this is t by here linear mass density, even we can write it as it's a mass per unit length of the wire you can take. Mass is nothing but volume into density. Volume you can write it as area into length of the wire into you can write it as rho by L you can take. So instead of linear mass density, even you can write it as A into rho. So here you just substitute as A into rho you can take. Now here when you are squaring on both sides, v square which will be equal to t by A into rho will be getting. So we would like to calculate the tension in the string. T equals to you can take as v square into A into rho you can take. V value we calculated as 30 whole square means 900 into, so area it's given as 1 millimeter square, you just convert into meter square, that means 10 power minus 6 meter square, into it's given as 8000 kg per meter cube it's given. And here you can take 1 2 3 4 5 zeros, and here it will be 10 power minus 1. 9 into 8 will be getting as 72. 72 into 10 power minus 1 will be getting. So here the tensional force will be getting as 7.2 Newton you are getting. This is the correct answer. Let us see the next question. The next question says a transfer wave is passing through a light string shown in the figure, and the equation of the wave is given as y equal to a sin omega t minus kx. The area of cross section of the string is given as a, and density is given as rho. The hanging mass they are asking. You know, here y equals to, it's given as, this is a sin, here you can take as omega t minus kx. Then velocity of the wave here you will be getting as, the formula will be omega by k will be getting. Then here velocity of the transfer wave, the formula will be getting as v equals to, you can take as root over t by mu, which will be equal to, you can take as omega by k you can take. Whereas here in this case, here tensional force here it's going to be supported by the weight of the body, you can take as mg you can take. So here it is mg by mu, you can write it as again linear mass density you can take, and in terms of the area, in the sense linear mass density, you can write it as a into rho you can take. So instead of mu I am just replacing as a into rho under root, which will be equal to omega by k you can take. Here we would like to calculate the hanging mass. We just square on both sides, mg by a into rho, square and root gets cancelled, it's nothing but omega square by k square you are getting. With this here mass of the hanging one, which will be equivalent to, just cross multiply this one, it's omega square into omega square into here a into rho by, here you can write as k square, into will be getting as g will be getting. So a into rho into omega square by k square into g will be getting. So this is the hanging mass will be getting. So k square into g, and here this is omega square and a into rho. Third one is the correct answer. Let us see the next question. The next question says the velocity of the transverse wave in a stretched wire is given as 100 meter per second. If the length of the wire is doubled, length of the wire you are going to be doubling, and the tension in the string is also doubled, then find the final velocity of the transverse wave in the wire they are asking. So velocity of the wave, transverse wave, the formula will be getting as v equals root over t by mu. Here length, if you are doubling means, here what will happen means, students, here this is the initial mass, initial length of the wire you are taking, this is the length, and this mass you are taking as m you are taking, and here length you are going to be doubling, then it becomes length it becomes 2l, in the sense here mass also it becomes 2m will be getting. So linear mass density, in the sense here mass per unit length, if length is increasing, mass also it's going to be increases, so mu always remains constant will be getting. So here this one you will be getting as constant value, then v is directly proportional to root t will be getting. Then here with this, here you just calculate v2 by v1, which you can take as root over t2 by t1, and tension in the string is double they have given, so v2 by initial velocity is given as 100, which will be equal to, this is 2 times of the initial one, and initial tension you can take as t, so which is nothing but 1.414 will be getting. Then v2, which will be equal to 1.414 into 100, which will be equivalent to 141.4 meter per second will be getting. So this will be the correct answer. Let us see the next question. Two strings is given A and B, made up of the same material. Same material is given, having equal lengths is given. The cross sectional area of the A is area of cross section A is given, area of the A is given as half that of the B is given. That means here area of the B by 2 you can write, half that of the B. And here while tension on the wire A is given as, tension on the wire A is given as twice that of the tension on the B wire it's given. The ratio of the velocities of the transverse waves A and B they are asking. Now here I just look at students, here velocity of the transverse wave, the formula will be getting as V equals to root over T by mu. So in terms of the area, in the sense here A into rho you can take, same material wire in the sense density you can make it as constant. So here you can take as V is directly proportional to root over T by A will be writing. So the ratios of the velocities of the A and B they are asking. So you can take as VA by VB, which will be equal to, you can take as tension A to the tension B you can take, and area of cross section of the B wire to the area of cross section of the A wire you can take. So tension in the wire A you can take as 2 times of the tension B by here tension in the B you can take as it is. Area of the B you will be getting as 2 times of area of the A you can take, which will be by here you can take as area of the A you can take. So here area gets cancelled, TB gets cancelled, 2 2s are 4 will be getting, square root of 4 means here will be getting as 2 will be getting. So ratio of the VA is to VB, velocity of A is to B, which will be taking as 2 is to 1 will be getting. Let us see the next question. The next question says 2 strings A and B is given, made up of the same material. Same material in the sense here you can take as density remains same you can take. Same material, rho remains same you can take. Are stretched by the same tensional force. Here tension also it's given as same is given. The radius of the string A is given as, radius of the string A is given as double the radius of the B is given. A transverse wave travels with a speed VA is given, and here on the B is given as VB, the ratio of the VA by VB they are asking. So velocity of the transverse wave, the formula will be getting as root over T by mu. In terms of area, in the sense here we will be getting as T by A into rho will be getting, which is nothing but T by here you can take as pi into R square you can take, into rho you can take. So here tension given as same is given, same material is given, pi of course is a constant value. So then V is inversely proportional to, here will be getting as 1 by R square. So it's nothing but square and root gets cancelled, V is inversely proportional to R you can take. That's nothing but here you can take as velocity of the A by velocity of the B, which will be equal to radius of the B by, you can take as radius of the A you can take. So radius of the B by here radius of the A is given as 2 times of the radius of the B. So radius of the B gets cancelled, here we will be getting as velocity of the A to the velocity of the B value will be getting as, that is 1 is to 2 will be getting. So here it is velocity of the A to the velocity of the B will be getting as 1 is to 2. So here it is 1 by 2 is the correct answer. Let us see the next question, students. A rope of length is given as L and mass is given as M, hangs freely from the ceiling. If the time taken by the transverse wave to travel from the bottom to the top of the rope is T. So then the time to cover the first half of the length they are asking. Here you just look at, students, here you are suspending a rope, and here this mass is given as M is given and its length is given as L is given. So here you are producing a transverse wave, here it's going to be traveling like this. Now here at a particular point here we just calculate the tension in the string. This is X distance you have to take, and total mass is M. Here a mass at a particular distance X, here we just calculate. Then mass at a particular distance is nothing but here you can take as M dash equals to total mass by total length into here at a given distance you can take. This is the mass at a particular distance X will be getting. Then V equals will be getting as root over T by mu. which is nothing but here we can get it as T in the sense here we can get as m dash into g by will be getting as here mass per unit length you can get. When you are substituting this value m into x by L into g by, here we will be getting as m by L you can take, and here this m by L and m by L gets cancelled. So velocity, the value will be getting as root over x into g. So at a particular distance, here the velocity value will be getting as root x into g. Now here the time taken to cover first half of the length they are asking. Here let us calculate the distance or time taken to cover the distance. Now here velocity, when you are taken as it's a ratio of the change in displacement by change in time, which will be equal to, you can take as root over g into root over x you can take. So here dx by root x you can take, which will be equivalent to root g into dt you can take. So when you are integrating on both sides this value, now here you will be getting as here distance limits you can take from 0 to L you can take, and here this is 0 to t you can take. So here 1 by root x you can take, here it's in the form of x power minus 1 by 2 dx. So it is in the form of x power n dx will be getting, the formula will be getting as x power n dx will be x power n plus 1 by n plus 1 will be getting, which is nothing but minus 1 by 2 plus 1 by, here minus 1 by 2 plus 1 will be getting, it's nothing but x power minus 1 by 2 by, sorry, plus 1 by 2 by 1 by 2 will be getting. It becomes here when you are doing integration, here will be getting as 2 into root x will be getting, but in the limits you have to take as 0 to L you can take, which will be equivalent to root g into integral dt is nothing but root g is the constant you can take outside, integral dt is nothing but here will be getting as t will be getting. So here when 2 into here we can take as root L, and here this z value also you just bring into the denominator, root L by g will be getting 2 into root over L by g, which is nothing but the time will be getting. So this is the basic formula here, right? Time taken to move from one end to the other end. Here they are given as, so if the time taken by the transverse wave to travel from the bottom to the top, bottom to the top is given as t is given, this is given as t is given, then the time taken to cover the first half of the length. First half of the length means here from this same formula t dash, which will be equal to 2 into, here you can write as L by 2 into g, you can L by 2 by g, you just bring into the denominator. Now here we can write this one as 2 into root over L by g, 2 into root over L by g is nothing but t, here we will be getting as t by, it's under root you can take. So here t by root 2t is the correct answer. So this is the velocity you can take at a given distance, and here in coming problems also here right, time taken to reach from bottom to the top in the sense 2 into square root of, here we will be getting as root over L by g will be getting. Let us see the next question. The next question says here the tension in the string is changed by 2%. So what is the percentage change in the transverse wave velocity they are asking? So velocity of the transverse wave, the formula will be getting as v equals root over t by mu. That means here velocity is directly proportional to root t you can take. So here it's nothing but for small changes delta v by v into 100, which will be equivalent to here you can take as, it's nothing but t power 1 by 2 you can take, 1 by 2 into you can take as delta t by t into 100 you can take. The tension in the string, here it is changes by 2% is given already. Here this value is given, delta t by t into 100, that is 2% is given, and 2 one time it's going. So here we'll be getting as, so it's a 1% will be getting. So change in velocity will be getting as, in terms of the percentage will be getting as 1%. Let us see the next question, students. The density of the stretched string is changed by, here 2% is given, and the next without changing the tension and as well as the radius, the change in the transverse wave velocity they are asking. So density alone it's going to be changes. You know, here velocity of the transverse wave, the formula will be getting as V equals to root over T by mu. In terms of density means T by, here you can take as A into rho you can take. That means here you can take as V is inversely proportional to, here you can take as rho you can take. That means here when you are taking this side, here it's so you can write it as rho power minus 1 by 2 you can take. That means for small changes, delta V by V into 100, which you can write it as minus 1 by 2 into, you can write it as delta rho by rho into 100 you can take. So it's given as delta rho by rho into 100, it's given as here already 2% is given. Delta rho by rho into 100 value is given as 2% is given. So it's minus 1 by 2 into, you can take as 2%. 2 1 times here will be getting as minus 1% will be getting. So that means here you just look at just changes is given, whether it is increased value or decreased value they are not given. So means here if V is inversely proportional to, here will be getting as root over rho will be getting. If density here it is increases means, if density is increased value in the sense here V it should be a decreased value. If rho is a decreased value, so then speed will be an increased value. Here you just take from this relation you will be getting. If it is a decreased value, it should be an increased value. If it is an increased value, it should be a decreased value will be getting. So both the factors we may get. So 1% here it may be an increased value or decreased value will be getting. Let us see the next question, students. Here a uniform rope of mass is given as 0.1 kg, of length is given as 2.5 meters. So here this is rope is given and this mass is given as here 0.1 kg and here its length is given as 2.5 kilogram, 2.5 meter it's given, hangs from the ceiling. This is a rigid support you can take. The speed of the transverse wave in the rope at the upper end and at a point 0.5 meters distance. So you are producing the transverse wave like this. Here the wave is going to be traveling. Here speed they are asking. In the previous case we have seen velocity V equals to, at a given distance the formula will be, the basic formula you can take as root in G into X you can take. That means here we will be getting as, at a given distance, the speed of the transverse wave in the rope at the upper end. At the upper end in the sense here we will be getting as total length you can take, students. V at the upper end which is nothing but, so root G into total length you can take, which is nothing but here you can write it as 10 into total length will be getting as 2.5 meters. 2.5 into 10 will be 25, which is nothing but 5 you can get. This is a 5 meter per second at the upper end will be getting. And velocity at a given distance in the sense, speed at a given distance in the sense root over G into X. And here at X distance here what they have, 0.5 meters, 10 into you can get as 0.5. So you can get it as 5 will be getting. So this is nothing but root 5 you can take. So speed value nearly will be getting as 2.24 meter per second will be getting. At the upper end will be getting as 5 meter per second. At the distance 0.5 meters, 2.24 meter per second will be getting. Let us see the next question, students. Here they are given as transverse wave of same frequency is given or generated in the two steel wires A and B. The diameter of the A is twice that of the B is given. So diameter is directly proportional to radius you can take. That's nothing but here you can get it as radius of the A wire, which will be equal to twice of the radius of the B wire it's given, and the tension in the A wire it's given as half that of the B is given. Half that of the B is given. The ratios of the velocities they are asking. So velocities ratio they are asking. Now here velocity of the transverse wave in terms of the radius, the formula will be root over T by mu, which will be equal to T by here mu, even you can write it as A into rho, which is nothing but T by here A in the sense here you can write it as pi r square into rho you can take. Now just bring the relation between tensional force and radius and as well as the velocity. V equals to, here you can take as root over T by square root of r square, in the sense here we will be getting as r will be getting. So this is the relation we will be getting. Now I just substitute the values. So speed of the ratios of the velocity of the A to the velocity of the B, which will be equal to tension the wire A to the tension the B wire, it's under root, into radius of the B by U conductors, radius of the A conductor. So it is nothing but here we will be getting as tension the A wire, it's given as TB by 2. So by TB will be getting, it will come to the denominator, into, it is inside the root, radius of the B by radius of the A wire is given as 2 times of the radius of the B is given. RB gets cancelled, TB gets cancelled. Here we will be getting as velocity of the A to the velocity of the B will be getting as 1 by, this will be outside the root 2 will be getting in denominator. So you can take as 1 by 2 root 2 will be getting. Let us see the next question, students. Here in the given arrangement, if a hanging mass will be changed by 4%, then percentage change in the wave speed of the string they are asking. So here velocity of the transverse wave, here velocity of the wave, the formula will be getting as V equals to root over T by mu you can take. So here tension can be supported by, in the both the sides here will be T can be balanced by the weight of the body you can take, which is nothing but here you can take as mg by mu you can take. So if the hanging mass is going to be changed by 4%, the percentage change in the wave speed they are asking. That means here V is directly proportional to root m you can take, which is you can take as whole power m by 2 you can take. It's nothing but here you can take as delta V by V into 100, which will be equal to 1 by 2 into you can take as delta m by m into 100 you can take. And here this value is given as, here mass is going to be changes by 4% is given. So 2 times here. So that is delta V by V into 100 will be getting as 2% change will be getting. So 2% change is the correct answer. Let us see the next question. A wire of 9.8 into 10 power minus 3 kg per meter passes over a frictionless light pulley fixed on the top of the frictionless inclined plane, which is making an angle 30 degrees to the horizontal. Means here you are taking on inclined plane, you are taking, students. And here there is an inclined plane is given, and here you are taking, which is making an angle 30 degrees to the horizontal is given, and here a frictionless pulley, here it will be located. Now here you are going to be hanging the two masses small m and capital M are tied at the two ends of the wire such that small m rests on the plane. So here you can take as small m is the mass which is going to be resting on the plane you can take, and capital M is going to be hanging freely vertically downwards. So now here you can take, this is capital M, it is going to be hanging vertically down. The entire system is in the equilibrium and the transverse wave propagates along the wire with the velocity is given as 100 meters per second. Choose the correct statement. Now here at this position, here we just take, students, here this is here weight, it's going to be acting downwards mg, and here this will be normal reaction will be getting when you are extending this one, here it will be 30 degrees, it is mg cos 30 will be getting, and this side will be mg sin 30 will be getting, it is mg sin theta. Here tensional force, here it's going to be, here you can write as T, and this side also here will be getting as T will be getting. So here a system, it is in equilibrium is given. So here you can talk about at equilibrium. So what are the balanced forces in the sense? Here you can get this tensional force which is going to be supporting the capital mg you can get. So here mg sin 30 which will be equal to T. T is nothing but here you can write it as mg you can take. So here GG gets cancelled. This is m into sine 30 value will be 1 by 2, which is nothing but here you can get it as capital M you can take. So capital M equals here will be taken as m by 2 you can get. Now here velocity is given. Here v equals to here you can take as root over t by mu. So velocity here it is given as 100 meter per second, which will be equal to tension is nothing but here you can take as mg by linear mass density is given already. Here it is 9.8 into 10 power minus 3 it's given, which is nothing but here you can take as m we don't know. Here g value it is 9.8 by here you can get it as 9.8 into 10 power minus 3 you can take. Here this 9.8 gets cancelled. When you are squaring on both sides, here we will be getting as 10 power 4, which will be equal to m into, it will come to the numerator, it becomes 10 power plus 3. This is the value. So 10 power 3 and here 10 power 3 gets cancelled. Here mass value will be getting as capital M value will be getting as 10 kg. This is a capital M value. And here a small m, when you want to take here from equation 1 what you can take, small m equals will be getting as 2m will be getting, then here 2 into 10 which will be equal to 20 kg is the answer. Here at this position here you can take square on both sides students. Here a square and m into 10 power 3 will be getting. Let us see the next question. The next question says a uniform rope of length is given as 12 meter and the mass is given as 6 kg. It hangs vertically from the rigid support. A block of mass is given as 2 kg is attached at the free end of the rope. A transverse pulse of wavelength is given as 0.06 meter is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope they are asking. Here we would like to calculate its wavelength students. Here when you are taking here tension at the bottom when you are talking, here this is the tension. At this point here tension can be supported by this 2 kg mass. So T equals here we will be getting as 2 into G you can take. So here you can take, so tension at the bottom in the sense here you can take as that's nothing but mg. Mg is nothing but here you can take as 2 kg weight you can take. This is 2 g, you are take as 1 kilogram weight I am just taking. And here next thing is tension at the top when you are talking here at this point. At this point tension force in the sense here it will be at this point here 6 kg mass will be there, along with that 6 kg mass 2 kg mass also total weight it is going to be supporting. So tension at the top is nothing but here you can take as 2 plus 6 kg weight you can take, which is nothing but here will be getting as 8 kg weight will be getting. This is the tensional force value. Now here velocity the formula will be getting as v equals root over t by mu you can take. And here velocity at the top to the velocity at the bottom you can take, which will be equal to here you can take as it's directly proportional to root t you can take. Right, velocity is directly proportional to here you can take as root t you can take. So here Vt by Vb, velocity at the top to the velocity at the bottom, which will be equal to F into, here they are talking about wavelength. The wavelength of the pulse when it reaches the rope they are asking, top of the rope. So here V equal to, you know the formula, velocity of the wave, one more formula, V equal to F into lambda. F into here you can take as lambda at the top to the F into lambda at the bottom you can take, which will be equivalent to tension at the top to the tension at the bottom you can take. So here FF gets cancelled here. Now here you can take as lambda top to the lambda bottom you can take, which will be equal to tension at the top is given as it's a bottom, and this is the tension at the top you can take. At the top you can take here tension at the top to the tension at the bottom. Tension at the top is given as 8 kg weight. So 1 kilogram weight you can take as like 10 newtons you can take. By here we will be getting as 2 kilogram weight you can take as 10 you can take. This 10 gets cancelled, 2 4 z, so square root of 4 in the sense 2 will be rating. So here the wavelength of the pulse and it reaches the top they are asking. Wavelength at the top to the wavelength of the bottom is given as 0.06 meter. 0.06 you can take, which will be equivalent to T you can take. Now just simplify this one. Here wavelength at the top, which will be equal to here 2 into 0.06, which is nothing but here we will be getting a 0.12 meter we will be getting. This is the wavelength at the top value. Let us see the next question. The next question says a string of length is given as L hangs freely from the rigid support. The time required by the transverse pulse to travel from bottom to the half of the length they are asking. The time taken to travel the wave, here it will be the formula will be getting as T equals to 2 into root over L by G. This is the basic formula to travel. In the previous cases clearly I have explained you this relationship. So here now they are asking time required by the transverse pulse to travel from the bottom to the half of the length of the string. Bottom to the half of the length in the sense here you can take as T dash you can take 2 into here half of the length means here instead of L you can take as L by 2 you can take by G, it will come to the denominator. So here T dash which will be equal to 2 into, so here 2 you just take inside the root, so here we will be getting as 2 2s are 4 we will be getting, so 4 into L by here you can take as 2G you can take, here 2 times here T dash equals to here we will be getting as square root of 2L by G will be getting. So here this is 2L by G is the correct answer. Let us see the next question. The next question says here a uniform rope of mass is given as 0.1 kg and the length is given as 2.45 meters hangs from the ceiling. So here a rope you are going to be suspending and here its mass is given as, here it is given as 0.1 kg and here its length is given as 2.45 meter and the speed of the transverse wave in the rope is given as 0.05 meter distance from the lower end. So first case here the speed at the given distance we need to calculate. You know speed at a given distance formula when you are producing the transverse wave here like this. Speed here at a given distance the formula will be root over G into X. Here we just substitute this value here this is an A case you can take. Root G value you can get it as 10 you can take into X value here it is they are asking as at a point 0.05 meters. 0.05 meters you can take, which is nothing but here we will be getting as 0.05 into 10 will be 0.5 will be getting root over 0.5. Root over 0.5 is approximately will be getting as 0.7 meter per second will be getting. This is the first case. The time taken by the transverse wave to travel full length of the rope they are asking. Time taken to travel from top to the bottom, right here to here how much time it is going to be taking means T equals the formula will be getting as 2 into root over L by G. In the previous case I have explained you clearly 2 into here length of the wire it's given as it's a 2.45 it's given by here you can take as 9.8 will be getting, right, this is a 9.8. So when you are simplifying this value 2.45 by 9.8 and here now we will be getting as nearly this is 4 times it is going, which is nothing but 2 by here square root of 4 in the sense 2 will be getting 2 times here it will be how much time it will take in the sense here T equals will be getting as 1 second it will take. So the answer will be 0.7 meter per second and the second thing is here 1 second is the correct answer. Let us see the next question. The extension in the string obeying the Hooke's law is given is X. So that means here initial elongation is given as some X is given. The speed of the sound in the stretched string is given as V. So initial speed is given as V is given. The extension in the string you are going to be increasing 1.5x. So here this is E1 you can take and this is E2 will be taken as 1.5 times you are going to be increasing to the initial value the speed of the sound wave they are asking. So V equals the formula root over T by mu. In terms of elongation, in the sense, here you can get it as, by using Hooke's law, when you are going to be elongating, in the sense, here a tensional force which will be equal to, this is Y equals to here a tension by force by area, by you can take as delta L by L you can take. So here tension by area which will be equal to, here you can take as delta L by L, Y into just cross multiply this one, delta L by L is nothing but E by L you will be getting. So tensional force which will be equal to Y into A into E by L you can take. So V equals to speed, the formula will be getting as, instead of T you can write it as Y into A into E by L into mu you can take. With this here you can relate as V is directly proportional to elongation will be getting as root E will be getting. So now you just substitute the value here, V2 by V1 which will be equal to E2 by E1 you can take elongation. E2 is given as 1.5x by initial elongation will be x, x gets cancelled. So root over 1.5 will be getting, root over 1.5 value will be getting as 1.22 nearly. So then V2 which will be equal to will be getting as 1.22 times of the initial velocity will be getting. So this value is given as V is given already. Let us see the next question. The next question says here, a 4 kg block is suspended from the ceiling of an elevator through a string having a linear mass density is given as 19.2 into here a linear mass density is given, mu is given, this value is given as 19.2 into 10 power minus 3 kg per meter it's given, and the mass is given as 4 kg block suspended from the ceiling of an elevator through a string. So here this is an elevator you can take, and here you are suspending one string, you are going to be suspending like this, and this is a 4 kg block also you are going to be suspending. This is a 4 kg block also you are going to be suspending. Now here we will be getting as, find the speed with which a wave pulse can be travel on the string. So here with what speed it's going to be traveling. If the elevator is going to be accelerating up, here with what acceleration, 2 meters per second square it's given. So here I just take students, here velocity of the transverse wave, the formula will be getting as root over T by mu. So tension in the string which when it is moving up, in the sense, here you can take as, so V equals will be getting as this is similar to the lift case students. While you are going up, here T equal to M into will be getting as G plus A by, here you can take as mu you can take. Now just substitute these values here. What you can write here, mass of the block is given, and here it is given as 4 kg, and here G value you can take as 9.2 plus A is given as 2 is given, linear mass density is given as 19.2 into 10 power minus 3 it's given. And here when you are substituting this value, 9.2 plus 2 will be getting as 11.2, 11.2 into 4 will be getting as nearly, it's a 47.2 will be getting, by 19.2 you can take, you just bring into the numerator 10 power minus 3, it becomes 10 power plus 3. And here nearly when you are calculating this value, here this value will be getting as, so V equals will be getting as 2.458 into will be getting as 10 power 3, it's an under root, which is nearly will be getting as 2458 will be getting, it's an under root. So when you are substituting this value, velocity value, the speed of the wave pulse will be getting as nearly 50 meters per second will be getting. It's a 50 meters per second is the correct answer. Let us see the next question. The next question says here, a copper wire is held at the two ends by rigid supports at 30 degrees Celsius. The wire is just taut with the negligible tension. Find the speed of the transverse wave in this wire at 10 degrees Celsius. When the temperature you are changing, in this is V equals will be getting as root over T by mu. So here you are fixing a copper wire between the two rigid supports. These are the two rigid supports you can take. At 30 degrees Celsius it was very tight, it's given, and negligible tension. So here when temperature you are lowering, in the sense, here I can take this is a tension. So when temperature is lowering, in the sense here you can calculate tension force Y equals will be getting as Young's modulus, which is nothing but, so this is a tension force you can take, stress by strain you can take, which is nothing but delta L by L you will be getting. So delta L by L in terms of alpha, in the sense here you can get it as here you can take T by A, which will be equal to Y into you can take as delta L by L, and according to the coefficient of the linear expansion, del alpha equals you can write as delta L by L into delta theta is the change in temperature. Instead of delta L by L, you can write as Y into you can write as alpha into delta theta you can take, this is the T value, and here T by here A will be getting. So here then tensional force, which will be equal to Y into A into alpha into delta theta you can substitute. Then it doesn't mean here instead of T you can substitute Y into A into alpha into delta theta by linear mass density in terms of the area, in the sense A into rho you can substitute here. So here A into rho, when you are substituting here, A gets cancelled, then V equals will be taken as Y into alpha into delta theta by rho will be getting. So now I just substitute these values here, will be getting as V equals to Young's modulus, here it is given as 1.3 into 10 power 11, and alpha coefficient of the linear expansion is given as 1.7 into 10 power minus 5 it's given. Change in temperature, in this sense here you can take it as 30 minus 10 you can take, by density is given as 9 into 10 power 3 is given. So here 9 into 10 power 3 kg per meter cube. So this is all whole root you can take. Now just simplify this one, students. Here nearly the value will be getting as velocity of the wave will be getting as nearly 70 meter per second will be getting. This is the correct answer.